Hey guys, good morning. Well, I guess it could be good afternoon or good evening depending on the time that you are watching this. So we are entering our week 3 and we are going to start with 3.7, which is inverse functions. So we are going to start with this real world example. This example deals with temperature with Celsius and Fahrenheit. We're not going to focus on Kelvin, but it's mentioned. But converting between these can be done very easily. So for most of you guys, you've seen the conversion formulas. So F of C, which is just basically saying Fahrenheit, is equal to 9/5 C plus 32. So if I plug in a 0, I get 32. If I plug in 37, I get the 98.6 and so forth. Okay, but can we go backwards? So how can I convert that? Well, yeah, we can. So I give you that formula right there. So if I was to plug in the 32, you can easily see 32 minus 32 is 0. 0 times anything is 0, so therefore we get it. But how and why did that happen? So I'm going to show that to you. Okay, so basically what happens is to do this, you want to switch your X and your Y. So in this case, I'm going to switch my F and my C. So I am going to change this to say C equals 9/5 F plus 32. And so now what I want to do is I want to solve for the F. So the first thing I'm going to want to do is subtract that 32 from both sides. And of course, we can't actually subtract that, so I'm going to write it like that. Okay. Then we need to get rid of the 9/5. A lot of students want to tell me, hey, we divide by it. Okay, you're not wrong, but you got to remember that when we divide by fractions, we have to flip it. Well, the change means we got to multiply, and the flip it means by the reciprocal. So it's a lot easier just to multiply by the reciprocal. So this would be 5/9. The 9s would cancel and the 5s would cancel. So what you do to one side, we do to the other side. So notice we have F equals 5/9 C minus 32, which is exactly what we have right here. And that is why that works. Okay. So basically, this is what we call an inverse function. Okay, so this right here is your function notation. Inverse function notation is right here, and we just put an exponent of a -1. Now, the first thing I want to make sure is that you understand is that is not an exponent. So this right here is very important. That is not true. Like that, no. The inverse function notation is just the f -1 of x. Okay, so it's just read as f inverse of x. Okay. One cool thing is the range of f of x will now be the domain of the inverse, and the range of the inverse is the domain of the f of x. So everything flip-flops on these. So it's kind of cool. You just got to think kind of backwards. So like for instance, on this example, I give you a function, but I want to know the inverse of 70. So let's think about this. Originally, if I say f of x, this is an actual x. Okay, but when I say the inverse of x, this is actually a y value. Because I want to know what x value goes to that. So this is actually a y value. So here it is, which means my answer is 90. Okay, and that basically just means a car has traveled 70 miles in 90 minutes. Okay, so think about it. The range of f of x is now the domain of the inverse. So that is why we have to look at that y value. Okay, so it's coming from this right here. Okay, let's go test inverses. Okay, to test inverses, we just use the compositions that we learned in section 3.4. So basically, we take the g, we plug it into the f. If we get x, we're on the right track. But then we have to do it again, and we want to plug which one? I just forgot which one I said. So g goes into f, and f goes into g. So you got to do it twice. And if you get x's on both, then we're good. Okay? So we're going to take this and plug it in to here. So we are taking the g of x and plugging it into the f. So we're going to have 1/3 x squared. Okay, well, cubed. Guess I need some more coffee this morning. So 1 cubed is 1, 3 cubed is 27, x cubed is x cubed. Okay, now we didn't get an x, but I still want to go ahead and show you the other way as well. So we're going to plug that in there. So we're taking the g, we're plugging in the f, and we get 1/3 x cubed. And again, still, that is not an x. So therefore, these are not inverses. Okay, because remember, we have to plug in and get an x. Okay. Okay, let me switch back. Okay, so let's try it again. So we're going to take the g function and plug it into the f function. So the g goes into the f. So you have 1 over x plus, minus 2 plus 2. Okay, so the good thing is here, those go to 0. So we get 1 over x. We're going to multiply by the reciprocal. These all cancel. 1 times x is x. So on this one, we are doing good. But we got to check it the other way. So we want to take the f and plug into the g. So the f goes into the g. So 1 over x plus 2 minus 2. Okay. So here, so I can have more room, put the minus 2 over here. We're going to do the same thing here as we did right here. So we're going to multiply by the reciprocal. Those cancel, 1 times x plus 2 is x plus 2. And then minus 2, these cancel, so we're left with x. So we got an x both times, so therefore these are inverses. Okay, now if you guys want to pause the video on the next one and you give it a shot, go for it and see if you can get whether or not they're inverses before I do it. Okay. So we're going to take the g again and plug into the f, g into the f. So -3 times x minus 5 over -3 plus 5. These cancel. X minus 5 plus 5. These cancel. We're left with the x. Yay, that one worked. Now we are going to take the f and plug into the g. So the f goes, this way. So we're going to have -3x plus 5 minus 5 over negative 3. Now, I know some of you guys want to cancel those negative 3's. You cannot technically do that first. These have to be gone first. Then the negative 3's cancel, and you're left with an x. So therefore, this one is also inverses. Okay, so I'm hoping that this inverse stuff is not too bad for you. Okay, so the biggest thing is to verify if they're inverses, you plug them into each other. And if you get an x, they're inverses. Okay. Okay, let's see what's next. Inverse function values basically on a graph. Okay, so we're given the g function. So the first one says find g of 3. So basically just look at the graph. So here's 3. The answer is 1. So to help you out, you're going to start with the x and answer with y. Because remember, this is your x value. Okay. But now we're going to do the inverse one. Okay. So you got to remember now that this is the y value. So the answer to this one is 5. So to help you out here, you're going to start with the y and answer with the x. Okay. Okay. Inverse functions by algebra. Okay, so this next part we are going to find the inverses. Okay. Now on this one, we have to be careful with it because when finding the inverse, we have to make sure it's 1-to-1. So you got to check that vertical and horizontal line test. If you need to, look at the parent graphs to help you out. Okay. So here we go. So number 6, that is a linear function, so therefore it would pass the vertical and horizontal line test. So here are the steps for you. 1, change f of x to y, okay? Because basically we're going to be looking at these on repeat. So y equals 6x minus 2. Switch x and y. X equals 6y minus 2. Solve for the new y. So that means I have to add 2 to both sides. So x plus 2 equals 6y. And then I would need to divide by 6. Okay, so x plus 2 over 6 equals y. And then the last thing that it wants us to do is to rewrite it. So inverse function of x, x plus 2 over 6. Now, something else here, if you wanted to, I'm going to squeeze it right here. You could have divided everything by 6 like this, okay? And if you would have done that, your answer would have just been 1/6 x plus 2 over 6 would have reduced to 1/3. Okay, so either one of those would be fine for an answer. Okay, the next one is a square root function. So remember, square roots look like this. Okay, so therefore, as of right now, this one is considered 1-to-1. This one is a little tricky because the answer we're going to get is not going to be considered 1-to-1. But we could also restrict it if we wanted to. Okay, but we are going to follow the steps. So change this to a y. Switch x and y. Now solve for that y. So we want to subtract 5 from both sides. So we're going to have x minus 5 equals 3y minus 1. I'm going to switch colors for just a second. Okay, so one thing I want you to remember is to get rid of that square root, we have to square, which means this whole side has to be in parentheses when we square. So we're going to get 5x, x minus 5 squared equals 3y minus 1. So we're going to add that 1 to both sides. Whoops. Really need some extra coffee. Okay, and then we are going to divide by 3. And I'm going to show you the two separate terms on this one. So that means I'm going to write it like this. Y equals, I'm going to write 1/3 in front, x minus 5 squared plus 1/3. Okay, and then I'll rewrite it because I kind of ran out of room like this with the function notation. Okay, the only thing I don't like about this one is if you look at your parent functions, our answer is going to make a u, and that does not pass the test. However, our square root one does, so we're okay. But if we were going the other way around, we would definitely want to restrict that, and I will talk more about that at the end of the lesson. But because we are going from square root, we are okay because, of course, this one passes. Okay, let's go look at the next examples. Okay, now if you would like to, you are more welcome to pause the video and try these out. That is your call. But if not, let's get started. So for this number 8, first things first, we have to substitute a y in. So y equals 2x minus 1 over 3x plus 4. Okay. So now we have to, let me use my highlighter. You're going to cross multiply here. And of course, when we cross multiply, here, that's an understood one. So this one doesn't actually change. So we're going to have, oh, hold on a second. I got ahead of myself. Hopefully some of you guys were supposed to say, hey, Miss S, you're about to mess up. Hopefully you guys caught it. I only switched my f of x. I did not switch my x's and my y's. So I need this to say, hold on one second. See if I can get this to move for me real quick. Off on the side. Yeah, we'll do that. So I'm going to go this way. Let's not use an equal sign. We'll use this because I only have a little bit of space on this. There we go. I was about to mess up. Okay. So again, this gets multiplied with an understood 1. And then these get multiplied. So we are going to have 3xy plus 4x. And then this will equal the 2y minus 1. Okay, so first things first, we need the y's on one side, everything else on the other side. So I'm going to have my 3xy minus 2y, because I'm going to bring this one over here, has to equal -1, and I got to bring this one over here, so minus 4x. Okay. Next step is see how they both, let me use my blue. See how they both, oops, that did not turn to blue. Let me see if I can fix that. Okay, so that's not what I wanted to highlight. I seriously need some extra coffee today. I only wanted to highlight my y's. Okay, so they both have a y in common. So you want to take that y out, and you're going to be left with 3x minus 2, basically what's not highlighted, equals -1 minus 4x. Now I know I'm running out of room, but here, because I want to solve for y, I'm going to divide by 3x minus 2, divide by 3x minus 2. So I'm just going to come up here. So y equals -1 minus 4x over 3x minus 2. So we're going to just rewrite that with our inverse notation, and we are done. Okay. So we are good to go on this one. Sorry I had so many glitches on it. Better take another sip of coffee. Okay, so on the next one, if you want to pause the video, you're more than welcome to. Okay, so we're going to change to y. Switch. Now we're going to solve. So we're going to add 1 to both sides. Now remember, I'll switch colors for this. To get rid of a cube, you have to cube root. Okay, so that means cubed root of x plus 1 equals y. So I'm just going to rewrite that as an inverse cube and then x plus 1. And remember, there's nothing special with this one because it's a cubed root. It's not an even root, so we're okay. Okay, now graphing. So use the graph of f to draw its inverse. Okay, so we are going to use the graph to do the inverse. So this is what I like to do. So as of right now, these graphs are originally blue. So what I'm going to do is I'm going to just jot down the ordered pairs. Okay, so I'll come right here. So this one right here would be a -3, 0. This one is a -1, 2. This is 5, 3. And I'm going to go ahead and do example 11, 2. Okay, so let's see what we got. This one is -2, 4. This one, -1, 2. 0, 1. And as you can see, it gets really, really close. We could probably even call that like a half, maybe. If we went down to the 2, that could maybe be a 0.25. I don't know. Okay, well, I'm not for sure, just estimating there. Okay, so remember the thing with inverses. X's become Y's, Y's become X's. So the first thing I want to do is I am just going to switch them. So 0, -3, 2, -1, and 3 and 5. Okay, I'm going to do the same thing over here. I'm going to write my table this way because we're getting out of room. So this would be 4, -2, 2, -1, 1, 0, 0.5, 1, 0.252. Okay. Okay, so I'm going to go back to example 10. Let's see if we can graph them. So 0, -3, 2, -1, 3, 5. Something like that. Okay, so let's look over here at the next one. 4, -2, 2, -1, 1, 0, 0.51 maybe, like right there. 0.252 maybe right there. So as you can see, it's going to get close to this, but not touch it. Okay. However, I would like to take it kind of a little bit of a step farther. I'm kind of jumping ahead. In the next section, you're going to learn that that a graph of its function, its inverse, or mirror images of each other over the line y = x. So basically, they are reflections. Okay, so I'm actually going to show it to you on this one. So y = x is just the parent function. So that means if I plug in a 0, I get a 0. I plug in a 1, I get a 1. I plug in a 2, I get a 2, and so forth. Okay. And I'll just make this line dash because it's actually not part of the problem. Okay, so this is the, whoops, I was really hoping we went through a video without that happening. Let me see if I can get it. Okay, so I had one small glitch, so I don't know what I was saying, but that green line is the reflection line y = x for the function and its inverse. So what I'm going to do is I'm going to change colors real quick because I want to show you something. If you kind of like rotate your paper where it's a little perpendicular and you draw a line like this, the distance between this point and the reflection line will be the same as from the reflection line to here. That is one way to see that these are inverses of each other, is because since they are reflections, they are the same distance from that line. So if I come over here and I draw that same y = x line, okay, they are going to be the same distance from each other. It's a little bit harder to see because that one's a little curved, but if I go ahead and mark it up, I can switch that back to yellow real quick. Like if I draw a line like this, whoops, it did not change to yellow. Let me try that again. There it goes. Okay, this line from here to here will be the same distance from here to here. And as you can see, that looks roughly about right. Okay, last part, let me get that fixed back to green. Okay, last part of the notes, okay, is what I told you I would get to in just a second earlier, okay? What to do when they are not one-to-one. So remember a quadratic, okay, it passes the vertical line test, but it fails the horizontal line test, okay? And that's because, like for that example, if I plug in 2, I get a 4. 2 squared is 4. If I plug in a -2 squared, well, guess what? That's also a 4, okay? So that's what makes it not one-to-one. Now, the inverse of that is going to be a square root function, okay? But we have to be able to restrict that because in all honesty, we cannot find an inverse because it fails the one-to-one test. But I want you to also think about what a square root function is. It's that. And the domain is already restricted. It's from 0 and above. So basically what ends up happening is when you are given your problems, you are going to have to figure out where to restrict your domain so that inverses can be found, okay? We can take functions and restrict their domains so that we don't have anything repeating. So if you look here, if I restrict it to be, oh my gosh, so sorry. If I restrict this and say, hey, I only want 0 and above, then on that one, I can find its inverse. Okay. So you just kind of got to see what is going on. Okay. Oh, and the quick note says this is the reason why when we're solving equations, we must also or always include the plus or minus because we don't know what's going on. But we can always restrict it and do just the positive version if need be. Okay, so I have to find a domain on which these functions would be 1 to 1. Then I can find the inverse, okay? So I want you to think about these problems, okay? If I have just x squared, that's the parent function, and I say minus 5, okay? Then that means my parent function, I'll erase this in a second. There we go. Okay, there's the parent function x squared. All I'm doing is going 1, 2, 3, 4, 5. I am just shifting my graph down 5. That's all I'm doing, okay? So that means that this vertex right here is 0, negative 5. So notice this is kind of like the parent function. I didn't move it up, down. I mean, I did move it down. I didn't move it left and right. So I didn't change any of my x values. So because of that, then my domain will be 0 to infinity. That is what my restriction would be. Okay. I'm going to come over here on this one. Remember in transformations, if that is a plus, that means that this will go left 7 units. Well, if I am going left 7 units, then that means my graph is starting at negative 7, 0. Because I didn't go up, I didn't go down, so therefore I am staying on that x-axis. So for this one, my domain will be negative 7 to infinity. Now, if you wanted to restrict these to the negative version or whatnot, that's technically fine, but typically you will always see us go to the positive side, the right-hand side of that U. So if you can just find where the transformations moved it, then you just need the right-hand sign. So now we're going to finish the problem. So y equals x squared minus 5. We are going to switch them. So that means I need to add 5. And then I'll switch colors. I like trying to switch colors for some of this. We're going to square root both sides. So therefore, I have the square root of x plus 5 equals y. So my inverse is the square root of x plus 5. And we have a restricted domain on that, so it will work. Okay, same thing here. Y. Switch. Okay, same thing. I need to get rid of that square, so we square root. So we're going to have the square root of x equals y plus 7. Square root of x, and then we have to minus 7, and then we are done. Square root of x, and then minus 7 on the outside. So I hope that the inverses were not too bad for you. See you guys soon. Well, talk to you soon.